Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to the channel and hit the bell icon to get notified when I post my new videos. So today I'll be discussing the different thumb rules adopted for calculating the steel quantity at site. So as we all know that thumb rule for any construction practices help to speed up the estimation process. So based on the thumb rules in the civil engineering, one can have an approximate idea of the cost and quantity of material as well as labor requirement for the construction practices. So here, as in case of the thumb rule adopted for the steel construction, so we have it also depends on the type of the building which has to be constructed. So here the thumb rule for calculating the quantity of steel for different types of building is as follows here. So whenever it is a residential building, so it is 4 to 4.75 kg per square feet. Now as in case of commercial building, it is taken to be as 5 to 5.5 kg per square feet, and for heavy structure or tall buildings, so it is taken to be as 6 to 8 kg per square feet. So here in particular, if we want to calculate the thumb rule of steel reinforcement for different structural elements such as slab, beam, column, etc. So we need to follow some important procedures for that. So in particular, as of now, in case of slab, so the minimum thickness of the slab should be equal to 120 mm. So here again, the minimum diameter of the slab, the minimum diameter of reinforcement used in the slab should be 8 mm. So the clear cover of 15 to 20 mm should be provided, and the maximum diameter of the bars used in the slab is 1/8 times of thickness of the slab. And as in case of steel reinforcement in the slab, so it is equal to 1% of total volume of concrete. So in order to have a better understanding of this, so I have taken an example here. You can just observe here. I have taken a slab of size equal to length 5.5 meters, width 4.5 meters, and depth of the slab as 120 mm, that is 0.12 meters. So the total volume of slab comes on to be a multiplication of length, breadth and depth, that is 5.5 into 4.5 into 0.12 comes on to be 2.97 meter cube. So in order to calculate the quantity of steel, it is given by volume of slab multiplied with density of steel and percentage of reinforcement in the structural member. So here the volume of slab is calculated to be as 2.97, and density of steel is always equal to 7850 kg per meter cube, and percentage of steel reinforcement, it is taken to be as 1%, so that is nothing but 0.01. So if you just multiply that, you will get 233.14 kg, so that is nothing but 0.233 tons. So 0.23 tons of steel is required for 2.97 meter cube of slab volume. So this is how we are supposed to understand. And one more thing, it is the reinforcement in the slab. When we put the reinforcement in the slab, the spacing between the reinforcement should not be less than 150 mm center to center. So these are all some of the specifications and the thumb rule which are adopted for steel reinforcement as in case of slabs. Now, as in case of different structural elements, so in case of beams, the steel required in the beams is equal to 2% of total volume of concrete in the structural member. So as in case of beams, the minimum clear cover should be equal to 40 mm, and minimum 4 bars shall be provided in the beams, 2 bars at of 12 mm at top and 2 bars of 10 mm at bottom. This is a very important thumb rule for providing the reinforcement. And also the same spacing which is as that of slab. The minimum spacing between the reinforcement should not be less than 150 mm center to center. So this is the basic thumb rule which is adopted for beam. Next is the column. So when you just take up the thumb rule for the column, the percentage reinforcement for the column is considered to be as 2.5% of total volume of concrete in structural member, and minimum steel required is 0.8 percentage for as in case of footing, 0.8% as in case of footing. And then maximum steel is 6% of gross area of column. When you take up the clear cover, it should be equal to 40 mm. 40 mm, it is the minimum clear cover as in case of the column. And minimum size of the column should be equal to 9 inch by 9 inch. Should be equal to 9 inch by 9 inch. So this is this is for the minimum size of the column should be minimum. It should not be less than 9 inch by 9 inch. So next, maximum spacing of the stirrups should be 16 times of diameter or 300 mm, whichever is lesser. So these are the basic thumb rules for the column. So next is coming on to the percentage of steel reinforcement as in case of footing. It should be equal to 0.8% of total volume of concrete, and clear cover is equal to, for main reinforcement as in case of footing, it is equal to 50 mm. So minimum 10 mm diameter bars shall be provided, and the thickness of the footing should not be less than 40 centimeters. So thickness of the footing should not be less than 40 centimeter, and pile foundation should be used if SBC of the soil is less than 24 kilonewton per meter cube. These are the very important thumb rules which are adopted for the foundation or footing. So these are the very important things which should be kept in mind while construction of any structure. So next, coming on to calculation of weight of steel per meter length. So generally the weight of the steel is calculated with reference to the very generic formula that is given by d square by 162. So for 1 meter length of the steel bar, so the weight of steel is equal to d square by 162, where d is the diameter of the bar or diameter of the reinforcement. So in specific, if we want to calculate what is the length of the what is the weight of the steel for different length of the reinforcement, then it is given by d square by 162 times of length. So this is the important concept. So in particular, if you want to understand in better sense, then I have taken one example. If the diameter of the reinforcement, say for example I have taken it as 8 mm, then for 1 meter length I need to calculate what is the amount of weight of steel which is required for the diameter 8 mm. Then it is 8 square by 162, where d is 8. So d square, that is 8 square divided by 162 times of L, where L is equal to 1. So you will get the weight of steel for 1 meter length as 0.395 kgs. So this is how we need to calculate weight of steel bars for the given length of reinforcement. So thank you for watching. Please like, share and subscribe the video. Thank you.